Welcome to the Deep Dive. Today, we're plunging into, well, one of medicine's most incredible achievements, organ transplantation.
It really is amazing stuff.
Truly, it helps tens of thousands get their lives back. But there's this persistent challenge, right? Despite hitting a record, over 48,000 transplants in 2024, the waiting list just keeps growing.
Yeah, tens of thousands still waiting, often against the clock.
Exactly. So the mission for this deep dive is to explore how we're making organ allocation, smarter. It's a critical step, really, to make this marvel more equitable for more people. Okay, let's unpack this. This isn't just about, minor tweaks. We're talking about how significant policy changes, advanced metrics, and cutting-edge artificial intelligence are fundamentally reshaping this life-or-death process.
That's exactly right. These aren't just small adjustments, they're fundamental shifts. The goal is to maximize the use, the utility of every single donated organ and make sure access is fair. We'll look at three main areas. First, those foundational policy reforms, the new rules of the game, essentially. Second, how the scoring metrics for organs and patients have evolved, getting much more precise.
Okay.
And third, the really exciting part, perhaps, the role of AI and machine learning in optimizing the whole thing.
Let's start right there with the policy reforms then, because, they really are the bedrock for everything else that's happening.
Absolutely. So one of the biggest changes is this move towards what's called continuous distribution. The OPTN board approved this concept for all organs back in December 2018.
Okay.
It basically got rid of the old, very rigid geographic zones and strict categories.
And replace them
With a much more flexible points-based system.
So what's the real difference here? How does a point system change things compared to, say, drawing a line on a map?
Well, the key is that it allows for optimizing across multiple dimensions at once. This composite allocation score, it factors in medical urgency, donor-recipient compatibility, things like blood type, patient access, even placement efficiency.
So it removes those hard boundaries. We're not stuck with these sort of binary choices based just on geography anymore.
Which means you can find matches that might have been impossible before. More equitable, maybe?
Exactly. More equitable and more transparent because the decisions are based on a much richer set of data, not just where you live. It allows for more nuanced choices.
That makes a lot more sense. Less like a strict border, more like a gradient, weighing different factors.
Precisely. A good example is the lung transplant system. They switched to this continuous distribution model in 2023. Now they use a single lung composite allocation score, or CAS, for every candidate.
Okay.
And similar work is happening now for kidneys and pancreas allocation. They're using pretty sophisticated methods like analytical hierarchy processes to figure out how to weight different factors and simulation modeling to test it all out.
So really trying to fine-tune it based on clinical need, not just location.
Right. Getting away from those cruder geographic or category cutoffs. And I read there's already some promising early evidence. Something about an AI-driven algorithm from a UNOS-MET collaboration.
Yes, that's shown really significant potential for improving fairness and tackling those geographic disparities we saw with the old system.
Yeah.
It does this by integrating multiple variables, urgency, wait time, distance, all of it into one score.
So how did it manage that? How did it break down those old barriers?
Well, fundamentally, it allows the system to consider a much, much wider pool of potential recipients simultaneously. It's not restricted by those arbitrary geographic lines anymore.
I see.
The algorithm intelligently weighs all those factors to find this sort of best overall match, not just the closest one or whoever's next in line locally.
Interesting. Okay, so beyond the point systems, another big policy shift was moving away from local first allocation. That sounds logical on the surface, but what was the actual downside?
The big problem was inequity. Your chance of getting a transplant could vary dramatically just depending on where you lived, which meant equally sick patients in different regions could have vastly different waiting times, purely because of geography. It just wasn't fair.
Right. So the fix was broader sharing. For kidneys and pancreata, since early 2021, organs get offered first within a 250 nautical mile radius, replacing the old DSA system.
Correct.
And for livers, since 2020, they use these acuity circles, 150, 250, 500 miles, prioritizing the sickest patients within that distance, even over less sick, local ones.
Yeah, shifting the priority.
Sounds like it's less about strict borders now and much more about need wherever that patient might be.
Exactly. And, as continuous distribution gets fully rolled out for everything, distance will just become one factor among many with a certain weight rather than a hard cutoff. That ensures broader opportunities for everyone.
Okay, another tough issue these reforms tackle is organ non-use or discard. It's just heartbreaking to think of viable organs going to waste, especially the ones considered maybe harder to place.
It really is, and it raises that critical question. How do we stop that from happening? UNOS and OPTN launched this expedited placement protocol, sometimes called accelerated placement, for these kinds of organs.
How does that work in practice?
Well, take kidneys with a high KDPI, kidney donor profile index, say 75% or higher. These are often seen as marginal. There was a pilot in 2023 where participating OPOs, the organ procurement organizations, could actually identify centers and candidates in advance who were willing to accept these organs.
Oh, interesting. So before the organ's even recovered.
Yeah, after making sure no top-tier urgent candidates needed it, they could offer it out proactively to those pre-identified acceptors.
So it's about giving centers the confidence, maybe removing some administrative hurdles to say yes to an organ they might otherwise pass on. It turns a potentially risky organ into a real possibility.
Precisely that, overcoming that inertia and uncertainty. The goal is clear. Cut down delays, reduce discards, basically fast-track these marginal kidneys to patients who can benefit.
Gets more organs used, shortens wait times. Makes sense.
And this aligns perfectly with what the National Academy of Sciences recommended back in 2022. They said, we need to make it easier for transplant centers to say yes and even set targets, like getting kidney discard rates under 5%.
Wow, under 5%. That's ambitious.
It is, but it shows the direction we need to go.
And underpinning all this, there's been a major overhaul of the system's infrastructure itself, right? Congress reformed the National Organ Transplant Act, NOTA, in 2023.
Yes, that was huge. It allows HRSA, the federal agency, to completely revamp the OPTN contract structure.
And this ended, what, nearly 40 years of UNOS being the sole contractor?
That's right. It opens things up for competition and hopefully more innovation.
So this OPTN modernization initiative,
Yeah.
what does that involve?
It means competitive contracts, updated IT platforms, much better data transparency, and an independent board overseeing things.
That's the practical aim here. Faster changes, better tech.
All of the above, really. Bringing best-in-class IT and processes to the OPTN, upgrading the matching algorithms, enabling open data sharing for research, and speeding up how quickly new policies get implemented.
So it's basically building a more agile, modern system.
Exactly. One that's ready to incorporate all these new tools, especially AI, much more seamlessly. A system built for the future, ready to adapt.
Okay, so those policy changes set the stage. Let's shift now to the tools themselves. The refined metrics for assessing organs and recipients, smarter scoring.
Right. And a key one here, especially for kidneys, is the Kidney Donor Profile Index, the KDPI.
Define that for us again.
Sure. It's a percentile score, 0 to 100%, summarizing the quality or maybe expected longevity of a deceased donor kidney. Lower score, longer expected function. It's based on the Kidney Donor Risk Index, the KDRI.
And how does that KDPI score actually affect allocation policy?
Well, kidneys with a KDPI of 20% or less so, the top 20% highest quality, are preferentially offered to candidates who also have top scores for estimated post-transplant survival, or EPTS, again, 20% or less.
Okay, that's called longevity matching. Why is that specific matching so important? What's the thinking behind it?
The idea is to maximize the total number of years that transplanted organs function across the entire patient population. You match the longest-lasting organs with the patients expected to live longest after transplant.
To get the most graft years out of each donated organ.
Precisely. The best use of that precious gift. And what's really important is that the KDPI and EPTS calculators get recalibrated every year.
So they stay current.
Exactly. The May 2023 update, for example, incorporated all the 2022 donor data. This keeps the indices accurate as donor characteristics change over time.
Now, KDPI is pretty specific to kidneys, but are similar ideas being used for other organs?
They are. Similar donor risk indices are being explored elsewhere. And that continuous distribution framework we talked about, it specifically allows for including organ quality as a factor in the score for all organs.
Makes sense.
A key example for livers is the MELD score model for end-stage liver disease. It was significantly updated to MELD 3.0 between 2022 and 2023.
What did that update do?
It substantially improved how well it predicts 90-day mortality. For instance, it incorporated female sex to account for physiological differences, like in creatinine levels, ensuring women weren't disadvantaged.
Okay, addressing a known disparity.
Right. And it added factors like albumin levels, making the predictions more refined, especially for the very ill. Similarly, for lungs, the old Lung Allocation Score, LAS, was replaced by the Lung CAS in 2023. That now includes things like frailty, giving a more nuanced picture of survival benefit.
So the clear trend is this constant refinement, optimization, updating scores, making them more precise, more equitable, exploring new ways to capture the real benefit of a transplant.
Exactly. Iterative improvement.
Yeah, here's where it gets really interesting, I think. How artificial intelligence steps in to make all of this even more powerful.
Yeah, this is where things get potentially transformative.
Because AI isn't just about, like, faster calculations. It's about finding patterns, right? Hidden connections in the data that we might miss,
Yeah.
like a superpowered detective.
That's a good way to put it. And one of the most direct applications is predictive survival modeling. AI helping prioritize patients by forecasting how they'll do, both on the wait list and after getting a transplant.
Can you give an example?
Sure. There's the Optimal Prediction of Mortality Model, OPM, for liver candidates. Developed around 2019, it's a machine learning model trained on, get this, over 1.6 million waitlist observations.
Wow.
And it was shown to predict 3-month mortality better than the standard MELD score.
How did it manage that? What makes an AI model outperform something established like MELD?
Well, it can handle many more variables simultaneously, and crucially, it can identify complex, nonlinear relationships between those variables that simpler scores often miss.
So it sees subtler patterns.
Exactly. MELD is good, but OPM could find those finer signals in the data. And the simulations were striking. Using OPM for allocation might have prevented an estimated 418 waitlist deaths in the group they studied.
That's incredible, a huge potential impact.
Yeah. And we're seeing similar models being developed for heart transplant waitlist mortality, too. The outputs from these AI models can then feed directly into those continuous distribution scores.
AI is also being used for donor-recipient matching, predicting outcomes for specific pairings.
Right. Gauging how well this specific organ might do in this specific patient. That level of precision is vital.
What kind of AI techniques are used for that?
Things like neural networks, random forests. For kidneys, for example, AI can predict the risk of delayed graft function DGF quite accurately by spotting patterns in both donor and recipient factors.
And avoiding DGF is important for long-term success, right?
Absolutely. It significantly improves long-term outcomes. AI is just very good at sifting through all that complex data to find those predictive signals.
And this goes beyond just matching blood type and size, presumably. It can handle more complex stuff.
Oh, definitely. It can integrate really complex immunological data like HLA antibody profiles to give a much more precise prediction of rejection risk, matching on a level we couldn't really do before.
Okay, so predicting survival, predicting match outcomes. But you also mentioned AI designing policies. How does that work?
Yeah, this is maybe the most advanced application. Using techniques like simulation and reinforcement learning, AI isn't just assisting decisions, it's helping design potentially better allocation policies from scratch.
Wow. Can you give an example?
There's a notable study in 2021, Votes et al., where they built a data-driven model that learned queuing policies. Basically, it learned when to assign an incoming patient to an available organ, or when it was better for them to wait for a potentially better match later.
So it was optimizing the trade-off between waiting time and expected survival.
Exactly. And here's the kicker. When they tested this AI-learned policy,
It did better.
it significantly outperformed the traditional allocation rules they compared it against in terms of added life years and fewer waitlist deaths.
So this isn't just tweaking existing rules. AI might be finding entirely new strategies that humans hadn't thought of.
Precisely. That's the breakthrough potential. It can explore millions of possible scenarios and learn what truly maximizes good outcomes in a way that's very hard to do manually. It could redefine what optimal allocation looks like.
That's fascinating. And AI, specifically machine learning, is also improving how we assess the quality of the donor organ itself.
Yes, another crucial area, particularly with image analysis. Think about biopsies.
Okay.
Deep convolutional neural networks, a type of deep learning, can analyze kidney biopsy slides, quantify chronic damage, and predict graft outcomes, often more consistently than subjective human grading.
More objective assessment.
Right. And similarly for livers, AI models can quantify the amount of fat or steatosis in biopsies. That's critical because very fatty livers have a higher risk of failure. These tools offer rapid objective data points.
It's not just biopsies. Other imaging, too.
Yeah, AI analysis is being applied to functional MRI, ultrasound, even analyzing post-transplant biopsies to predict rejection risk earlier, all feeding into smarter, more confident decisions about using each organ.
So we have all these powerful AI models being developed. The big question then is, how do they actually get used? How are they making their way into clinical practice right now?
Well, the most prominent example currently is the UNOS predictive analytics tool. It was rolled out nationwide for kidney offers between 2022 and 2023. It's deployed right inside DonorNet, the system clinicians use.
Okay, so it's integrated into their workflow. What information does it give them when an offer comes through?
It provides two key real-time predictions for the specific candidate being considered. First, time to next offer, basically, an estimate of how long they might wait for a similar quality organ if they turn this one down.
Ah, okay, the waiting game factor.
Right. And second, mortality likelihood, their predicted chance of surviving for 3 years if they stay on the wait list without this transplant.
That sounds incredibly useful.
Yeah.
How does having that data right there in the moment change how a clinician thinks about the offer?
It gives them a much clearer sense of the opportunity cost. Instead of just relying on gut feeling or static data, they have these dynamic predictions tailored to that patient and that organ offer. It helps weigh the pros and cons.
And has it made a difference?
It seems so. A pilot study in 2022 showed its use was associated with kidney offer acceptance rates increasing from about 16.8% to 19.7%.
Oh, it's a noticeable jump.
It is. And Dr. Jacob Mancy, a transplant physician involved, mentioned how the tool helped them make decisions that could potentially save them 6 months or a year on the wait list.
Wow, that's real impact. So this is the first nationwide deployment of AI actually in the allocation decision process.
That's right. But, and this is important, UNOS is very clear that it's a tool to supplement clinical judgment, not replace it. The final call is still with the human experts.
Got it. Now, besides direct AI prediction, you mentioned offer filters. Are those AI too?
Not exactly AI, but definitely data-driven innovations. Offer filters allow transplant programs to preset criteria for offers they know they'll almost certainly decline.
Like what?
For example, maybe donor age over 70 or a KDPI over 90%. Things they've decided aren't a good fit for their program or patients.
So it's like setting up rules in your email inbox to filter out spam. Huge efficiency gain, I imagine.
Exactly. The system can automatically bypass centers that have filtered out that type of offer. It speeds up the process, gets the organ to a center that will consider it faster, which reduces waste and cuts down allocation time. Smart, even if not strictly AI.
Okay, one challenge you hear about is data living in different places, right? Donor info here, recipient health records over there.
Yeah.
Lots of manual checking.
That's definitely a current bottleneck. Cross-referencing that information during a time-sensitive organ offer can be slow and prone to error.
But there's work happening on that front. I saw something about an NIH-funded project called Transplant AI.
Yes, by a company called Inform AI. They got a significant grant in 2024. It sounds like a huge undertaking trying to connect all these disparate data sources. What's the ultimate vision there?
The goal is pretty ambitious. Build an informatics platform that integrates all that donor and recipient data, and then use machine learning trained on over 1 million historical transplants and hundreds of variables to recommend the best recipient for each organ in real time.
Wow. So like a smart allocator system sitting on top.
Kind of. The idea is it could identify optimal matches much faster than the current, often manual process by having all the information in one place, analyzed instantly. That could dramatically speed up placement.
That would be a game changer for efficiency.
And AI isn't just about the matching, is it? It's creeping into logistics too. Transport, scheduling.
Absolutely. Think about optimizing organ transport routes and times, predicting travel delays, or coordinating complex multi-organ surgeries, managing operating room availability, surgeon schedules.
Even predicting supply and demand regionally.
Exactly. Using AI to predict where organs might become available and where the need is highest so resources can be allocated proactively. It touches the whole operational side too.
Okay, so stepping back, we've seen AI doing image analysis with neural networks, processing clinical data with random forests, even designing policies with reinforcement learning. You mentioned explainability being important.
Crucial. For clinicians to trust and use these tools, especially in high-stakes decisions, they need to understand why the AI is making a certain recommendation. It can't just be a black box. Building that trust is key for adoption.
So looking ahead then,
Yeah.
what does this all mean for what's next? Where is this heading?
Well, several exciting directions. First, tackling the complexity of multi-organ transplants like kidney, pancreas, or heart-lung. AI could be really good at finding the ideal candidates for those combined procedures.
Okay.
Second, optimizing long-term care after the transplant. There are AI tools emerging, like the iBox algorithm, that predict long-term graft survival. This can help doctors tailor immunosuppression beds, helping organs last longer, which in turn makes the initial allocation even more effective.
That makes sense, maximizing the long-term benefit.
Third, a big focus is on bias mitigation. Ensuring these AI algorithms provide equitable predictions across different demographic groups, actively working to reduce existing disparities in transplantation. You could even train AI, like reinforcement learning agents, with fairness as one of its explicit goals.
It's vital. And lastly,
Maybe the most futuristic idea, dynamic recipient selection. Instead of a relatively static waiting list, imagine an AI system constantly reevaluating all waiting patients every time a new organ becomes available.
so this is the whole pool on the specific organ and finds the absolute best match system-wide in that moment.
Potentially, yes. Picking matches that maximize the overall benefit, not just for one patient, but optimizing for the entire cohort of patients and the available organs.
So the big picture is this convergence, right? Policy reform creating the space, and technology, especially AI, providing the tools for a much smarter, more agile allocation system.
That's the vision. AI really does hold the potential to revolutionize organ allocation, predicting outcomes better, optimizing selection, ultimately improving efficiency and equity. It's becoming an integral part of the decision-making landscape, always, of course, in partnership with clinicians and under careful ethical oversight.
So here's a final thought for you listening. Imagine a future where, for every single precious donated organ, an AI system could instantly sift through everyone waiting and identify not just a good match, but the absolute optimal recipient anywhere in the country, based not just on who's sickest right now, but who will get the most healthy years from that specific organ, whose life will be most transformed. What if every organ could find its perfect home every single time?
And think about the profound impact that reality would have on the tens upon tens of thousands of patients who are still waiting right now, today. This journey into smarter organ allocation. It really is about optimizing a process where every single decision, every improvement can literally mean the difference between life and death.